Hello everyone, this is Xuhai. The paper I'm going to present today is Recognizing Unintentional Touch on Interactive Tabletop. Multi-touch tabletop are designed to combine the benefits of a physical table and digital computer. However, most tabletops, especially those with a capacitive display, cannot discriminate between touch events that are generated by different objects. Any part of a human body or metal can easily generate touch events on the tabletop. This makes users overly cautious during interaction to avoid triggering unwanted touches, driving the user away from a relaxed, natural experience. Several work has been done to recognize unintentional input on small-scale touchscreen devices. For example, Matcher and Colley studied accidental touches on smartphones during daily usage. Their model achieves a true positive rate of 79% and a false positive rate of 0.8%. Skillers et al. Looked into the simulacy on tablets, and their random forest model achieves close to 98% precision and a very small errors per stroke. However, tabletops can accommodate distinct interaction activities. They are more prone to unintentional touches due to their increased surface area in a wider range of possible inputs. For instance, users can easily lean on the tabletop or put an arm on the surface to support themselves. These actions will be far less common when interacting with smartphones or tablets. In this research, we leverage gaze, head, and touch data to identify and filter unintentional touches. Our intuition comes from human hand-eye coordination. Usually where we look is where we have interest, therefore where we touch. We aim to answer 3 research questions in this paper. First, we would like to have users to use digital tabletop as if an ordinary physical tabletop. Currently, however, the behavior patterns on these 2 types of tabletops are very different. But what's the specific difference? Second, can we train the model using gaze, head, and touch data to recognize and filter unintentional touches? And third, once you have such a real-time model and a new interactive tabletop, will users like it? What is usability? To answer the first research question, we conducted a user study to compare the current behavior pattern on the digital tabletop and a normal physical tabletop. Meanwhile, the data collected from this study can also be used to train machine learning models for later usage. We use the 2 factors within subject design. The 2 independent variables are the type of tabletop and the user posture, with a Latin square design. 12 users were asked to complete 2 common tasks on tabletops: map navigation and photo categorization. During the study, all of their behavior data, including touch, gaze, and head orientation, were captured through multiple tracking systems. And after the study, 2 researchers went through all touch data and annotated whether it is intentional or not, according to the behavior data and also the video recordings of the study. We briefly summarize our findings of behavior differences and the implications of feature extraction here. First, the majority of the gaze is in line with intentional touches, but not with unintentional ones. This reveals the importance of the distance between the gaze and the touch points. The second, a large number of unintentional touches are closer to the edge compared to intentional ones. This means sight distance might be very useful. Moreover, intentional touches usually involve just 1 to 3 fingers, while unintentional ones often appear in groups. The clustering of touch points can also be an interesting factor. In addition, historical behavior affects current touches. For example, sometimes gaze leads intentional touches shortly, and sometimes the unintentional touches cluster an area often spawn more unintentional touches subsequently. Based on these observations, we extracted 4 types of spatiotemporal behavior features. And using this feature, we compare a few machine learning models. Results show that the gradient boosting appears to be the best model. We implemented and compared other state-of-the-art baselines. Our best model significantly outperformed the baseline. To answer the final research question regarding the viability of the algorithm, we implemented a real-time filtering system by integrating the best gradient boosting model with the tabletop. Then, we invited another 12 users for the usability study. All users went through 2 versions of the table, one with our algorithm and one without our algorithm, with balanced order. They went through 1 map navigation task and the 1 photo categorization task, and then reported their subject feelings. And our model performs well on a new set of datasets, a new set of users with an F1 accuracy over 90%. And also according to their ratings, our new tabletop can successfully recognize their interaction intention and is more intuitive and more energy saving. To summarize, in this research, we propose to leverage gaze direction, head orientation, and screen contact data to identify and filter out unintentional touches. we investigated user behavior pattern differences when interacting with digital tabletops versus physical tabletops. We then used 4 spatiotemporal feature types to train machine learning models to identify touch intention. The gradient boosting model was able to classify unintentional touches with an accuracy over 90%. We then implemented a real-time filtering system. Our user study showed that our tabletop could provide a more natural experience. By linking users' gaze and head behavior to their touch behavior, our work shed light on the possibility of future tabletop technology to improve their understanding of users' input intention. With this, I would like to end my talk. Thank you all for your attention. Hope everyone is safe and healthy around the world. Happy to answer any questions. Thanks.